Hello. With all the fearful news articles and, misleading data, in general kind of fear that gets instilled um, by COVID-19. And I'd like to just take a little bit and use this as an opportunity to give an example for my students, students in the future, and certainly anyone who kind of wants to look at what's actually happening between states in a more objective way at the actual data that we have. So I want to start out with showing you the data. This data is from Worldmeter's website, which is really the same data that CDC and many other large bodies like the WHO are using as well. The WHO, the World Health Organization. So I have the state-by-state data here, and I've done some coding to illustrate a few things. But before I get into the data, I just want to begin with, really my research idea and kind of walk through this, both for students and then to show others, how I'm really doing research in an objective and planned out way on this particular topic. So one of the things that's come up that you've probably seen quite often is sort of the politicized, media-sized question of, and it almost comes out in like sort of a shaming way. It's like, how is your state doing? And are you flattening? Which states are flattening and all this? And a lot of that is then tied into sort of connected quickly into behavioral patterns. Are we sheltering in place? Are we wearing masks? So all these kind of things are sort of data's thrown at it as a way of trying to show us, like, which states are doing better or this kind of thing. But what I want to look at today is really start with a beginning point of comparing the data and look at a comparison between two key measures, and that is the total testing and the total cases. And along looking at some other things like death rate and comparisons by state. So I hope it will be helpful for my students and anyone else who is interested in this particular topic. So let's start from the beginning. For each of our students, and of course any data that you're starting, we're starting with a main idea. And one of the main ideas that we see right now is the statement that maybe you've seen and it's been made in different ways, is that the reason that we have more COVID cases, or any state has more COVID cases, is what? Because they're doing more testing. The reason this is important is because the rate of testing is variable all over in different places in each state, each city for that matter. And so COVID positive cases has been used as a measure of whether a given state curve is flattening and whether, more specifically, whether they're doing enough social distancing, masks, all those kind of things, shutting down, all these different places like the pool that I wish I could really go to right now. And so I want to kind of walk through this. So because of these wide variations, positive cases are going to tend to correlate with testing. As testing increases, so does positive cases. But one of the things is that one of the claims that is made is that some claim that rising cases prove that low-tech efforts aren't working, or certain states aren't doing enough of it. And what tends to happen is, like, for instance, like a state that is run by, more of a conservative governor, Florida, for instance, or California, that there's kind of a sort of almost an us and them thing that goes on, What I want to do here is there's no political motivation for any of this. This is really to show you real data and to try to ease fears, and also, of course, help my students along the way too. So my question we really want to look at is, what's the relationship between total tests and positive cases? In this case, my independent variable, my x is going to be the total positive COVID tests, and that is defined by state. And then my y variable is the total COVID cases, that y variable. So x being the the total tests, and y being the total cases. Gives us a nice little visual for us to look at. All this by state. So my alternative hypothesis or research hypothesis is that total testing will be related to or correlated with positive cases. Correlated is just another way of saying that there's a relationship. So that's my research hypothesis. Now the null hypothesis is just stating the opposite of that, in that there'll be no total testing among states will not be related to the positive cases. And then what I'm aiming to do is really from here to test this hypothesis. Now this is the reporting data. This is the end part, so I'm just going to slide this under here for a little bit so that hopefully no one actually saw my data before I showed you how I got it. So let me go over to the data and first of all just make a few observations before we get into the stats that I ran. First of all, just looking at, this is all descriptive statistics here. What I've done is ordered by death rate, and my death rate is, calculated by taking total deaths over total cases. And here's the thing that is so important to start with all of this. All of this data is reported data. It's sampled data. And the tendency, especially in these higher death rates, I'll talk a little bit more about this, is that these kind of, in these particular states, there's clearly been testing that's skewed into the direction of more symptomatic cases, which are also correlated with the more serious cases, clearly deaths. Someone with no symptoms doesn't die. I mean, these are obvious facts to state, but the range of responses of COVID-19 each of us experience, I think, is a key part of the real challenge. My view, and I'll show you this here, is that it's not so much COVID's death rate that's the real worry. It's that COVID goes undetected, and that it creates this great amount of fear as to whether do I have it, and could I spread it, and how is it going to affect me if I have, if I would have, conditions that might make my immune system more compromised, then that could be a factor as well too. But let's just take overall and look at some of the data. First of all, one thing you'll notice is the top 10 states for death rate are all in the Northeast. This is where, through the spring, this is totaling all the way through the spring, beginning really in March, when we saw our first case in Washington, is all of these states are located in the Northeast. Now, some exception here would be the Michigan, which is considered the Midwest, but it's really in the same area of the country. The same, of course, with the other states. It's not till we actually get down to Louisiana at number 13 that we have a state outside of the Northeast with a higher death rate. And so this can be revealing. And I'm going to sketch out a few ways as we go along here. Now let's shift down to the cases with the least deaths. Look at Utah, which I think Utah is a great example, because first of all, Utah's very spread out. But there's some population. We're talking, almost 3 million, much bigger than some of the tiniest states like Wyoming, for instance. But still, Utah, not a very populous state, pretty big state, spread out. What else do we know? Very dry. Climate tends to be warm. Through the spring, the weather in that area would be both more sunny, more dry, and less wet. And these are all three. These are the three conditions under which respiratory viruses like COVID thrive. And let's be clear, that viruses like COVID, they're going to behave the same way in the face of different conditions. COVID's not unique in that way. What's unique about COVID, as I've been saying along the way, is the way in which it can go easily undetected. And is actually a sign that it's not as deadly, quote, in terms of percentages of death, than maybe the media is trying to get us to believe, so that we'll read their articles and so that they can keep on making money. So, a couple other observations here. Maryland and Missouri are kind of like bellwethers of the country. And the reason I say that is that the overall death rate and some of these other parameters are correlating very well with these two particular states. So 4.6 death rate. Here we have two states in which the rate is very similar to that. And so we'll notice here that our mean, you could say, maybe looking at the mode, is clearly shows that the bend is, what happens is these cases, these top 10 states are going to drive the death rate up due to what? Their sampling is skewed toward symptomatic cases. This is just something that's been quite clear, and I can share my own example here of actually going in to help with a particular patient, masking up and doing all that. But when this patient wasn't actually didn't have COVID, and I recall reaching out and praying for the patient and touching their hand and thinking to myself, wow, this is kind of different, because now going away 2 days later, I heard that I was, that this patient tested positive. So I wanted to get a test, but I couldn't get one. Why? I wasn't revealing enough symptoms, even though I had an exposure. And I had another incident of potential exposure as well. The reason I say that is there's a real bend toward symptomatic testing for symptomatic cases only. Another couple other things I want to notice is just to take a case, a very dramatic case of comparison. And New York and California are really, really a good case. And I'm going to show you this visually. This is a plot of total, on the bottom we have your total tests, and then on the side we have the total cases. And what's interesting is the comparison of New York and California. Here we notice that New York has almost double the case, probably about 40% more the cases that California has. Yet, what can you say about the tests? The tests are actually very close if you look at each state. Let's go and have a look for a moment. So in California, we've got, 4.5 million tests. In New York, we have 4 million, just over 4 million tests. And yet what do we know? The actual cases in California is, almost half California, New York, sorry. And the reason I want to make this comparison is I think it's a good one in terms of both states took very seriously, in different ways. Probably California maybe took some a little bit earlier steps, but the idea that I want us to get across here is that the states, it's hard to compare them in another way, and it's this. New York is in the Northeast, where it's moist and cold and cloudy in the springtime, and we're a lot more cloudy than our area. So take California, more sunny, hot, and dry. These are conditions under which, COVID, any kind of respiratory virus, is not going to do well. It's not going to, it's not going to be past us easily. So this is an important comparison right there. And also, if you look down at the states that have the lowest death rates, what you can say is that, for instance, a state like Wyoming is not a state that you can even compare to New York. And in many ways, states that are in different regions of the country are more easy to compare. Like a great example would be Washington and Oregon. States that are relatively close to each other, have very similar climates, and populations, density, similar, although Oregon being a little bit less. So we learn a lot from this kind of data. I think one of the key things I want to remind us about is that this is all reported data. Anytime we're doing any kind of sampling and we're doing all this testing really to help make sure these people get treated and as a way of handling the public health crisis. We don't do this testing as a way of trying to understand the prevalence, for instance. We're seeing now more studies that show prevalence, and the way you do that is by doing randomized sampling. That's really a way of getting at that part of the data. So let's go now to start to answer the question of research question that I have posed. And I'm going to make this just a little bit bigger so folks can see things better. So I ran Pearson's correlation coefficients, and I kind of demonstrated that in the previous video for all countries if you want to look at some of the details of that. What I want to show you here is that my total cases with total tests, the correlation is stronger than anything that I've ever seen. I've worked with a lot of data as a research professor, a lot of students' data as well. You don't see these kind of correlations unless the data is like kind of cooked up, almost to, kind of illustrate some of these things. So a perfect correlation would be 1. We're talking 0.944. That is such a high correlation. And what I want to illustrate for students and for other folks is just how you really answer all parts of the correlation question. In Excel, when you do a multiple correlation, it will produce all the R values, which is the main correlation coefficient. But it doesn't report on some of the other ones that are important to answer questions following APA guidelines, using the best practices, both in really any kind of statistical analysis and doing reporting correctly. So in order to get the measures about significance, for instance, which is very important, the best way to do that is actually to use a regression. So as I mentioned, I did the correlation in the countries study, which you can look at. Here I want to show a regression, and I've also been showing you this plot here as well. So if we go over to, we can go ahead and select, let's select the total cases and new cases. Or actually, let's run the variable first and then do the selection. So we go to data, same as the correlation data analysis, and then we go down to regression, and we want to run a regression. Regression really is, again, trying to compare y with x and see if we can develop a kind of an equation, kind of a formula that it would help us, for instance, predict from knowing the testing. We can predict somewhat on, the number of cases that we get. So regressions are more for making some kinds of predictions. So in order to do this, my y range, I wish x was above y, but I always start with the x range, which is the bottom axis. So that's going to be all those cases right there. So you'll notice that I already populated some of this here. I want the labels, meaning that I want these to be on the top here. And my confidence interval by default is 95, which is fine. What that means is that I have an error rate of, which is, again, a standard practice, is plus or minus 5%. And so now I gave this an output range so that I could, kind of illustrate. I'm just going to put this in another area of the spreadsheet just so I can show you how it comes out. Okay, so let's go ahead and run this regression. And so this regression here is the same. I wanted to show you how I do it. This output is the same as what I've used up here and done a little bit of formatting, and so I want to kind of go over that now. So what I've done here is, again, a regression of what? On the x-axis I have total cases, on the y-axis I have, x-axis I have total tests, the y is total cases. I've run a regression, which is essentially me trying to develop some kind of a predictor, sort of a model for understanding this. That's what regression is used for. So one of the things that comes out from the regression is that the first stat that's reported is actually the Pearson's R. It's the same measure as the Pearson's R, and you'll notice that it's the exact same value, 0.944, that I obtained in the regression over here. I'm sorry, in the correlation. So this is the regression. And so that's the value. And the nice thing about the regression is that it takes you one step further and helps you to understand what change in positive cases, what percentage of that change can be attributed to changes in testing. And so we get that from this R squared value. And the statement, which is a pretty compelling statement to be able to make, is that 89% of the change in positive cases, can be attributed to what? Testing. Attributed to testing. Now, what this means is that the key, the key factor in positive tests, the most important factor is doing the testing. You can't have cases without testing. What this means then is that the rest of the variation, the 11%, can be explained by other factors, which are third factors. Now these are the factors potentially like, how social distancing is being done or degree of mass. But more likely, there's even other third factors involved, and that is especially on the topic of sampling, which is so important to this. Remember, sampling is an aim to get at the whole population. So in an ideal, in a perfect world, we'd all have little, which is probably scary to a lot of us, a little device that would basically show us, whether we're COVID positive or not. Wouldn't everyone love one of those things right now? I think there's kind of there's ethical issues along with that, which I won't really get into right now. But what I want to show, especially here for my students and any others that want to see this, the real statistics under the hood on this, that's what I'm showing here. So let's go back to the reporting now. So I'm going to report that I have a very high Pearson's R, which is this 9.44, which is almost 100%. And so one of the things that we need to know about our, the measure that we've done is to ask, is this a significant difference? Is this statistically significant? And this is something that I just never seen before with real data. As I said, having run so many correlations. I had to map this out to 25 decimal places to finally get to my first value, And so this is certainly much less than, your standard measures, which is your 0.05. In order for you to have significance, you have to be outside of that plus or minus 5% range, so that it's not that the change is not due to error, but it's real measured difference. So let's go back to how we would actually report on this. So we go back to our main document that I'm using to guide you through all of this. And this is our last step, which really is testing the alternative hypothesis, the research hypothesis, and then reporting it. So we've done the testing. Now I wanted to show you the APA style. Again, this is the agreed upon standards for reporting on this data. The Pearson's R value, 0.94. The degrees of freedom, which just means the number of the n, the number of observations, is n, 50 states minus 2. That's how it's calculated. And so what we were able to say, this is a statement that would be put in the report, would really go well in the abstract, for instance. The total reported the total reported tests and positive cases were found to be strongly and positively correlated. So again, this graph is just an excellent visual of this, and I wanted to kind of show you. I've labeled a few of the points, but what we see here is that New York falls on that high side of our line, which is basically our modeling line, and then California falls on the low side. But one of the things that makes the correlation stronger is this variation on both sides, and being able to see that model curve that goes between them. And to go down a little bit here, we'll see that Texas, Florida, Illinois is a little on the higher side. But what this means here again is that, what does it mean? The testing that's done in Texas, in Florida, and the cases that are found, the number of positive cases per test they're very close to each other. And so um, what that reveals a lot is that rate of testing drives the rate of positive cases. And other factors would have to be explored using real, you could say essentially that all the sampling that's done around the country is convenient sampling. It's convenient for what? For treating people. Yeah, we should absolutely be doing this testing. But the issue is that the testing is not revealed to sort of help us to understand, what the real danger is out there for COVID-19. As I've said in the other video that I shared, and this is, certainly widely known, supported by many strong epidemiologists, is that our known cases are just a small fraction of our actual real cases. So many of us all over the country at various points have probably been infected with coronavirus. We didn't even know it because there's so many asymptomatic cases. And I make the contention that the danger with COVID is actually that aspect of it, and others have mentioned it too. It's the undetectability, which means that what we're really looking at difference with this particular virus is that it especially tends to hit people with a compromised immune systems. And so people that are generally more healthy, as a number of articles had said, the average immune system of an American can handle COVID-19. So I guess I want to just make a couple more statements that are really along the lines of just sort of wrapping this up. I've for my students have kind of shown the key reporting aspects. Let me just touch on a few things, more things that we learn from the data that we've come to. Well, first of all, our total cases, they're going to track right along with the total population. This just makes sense. That, of course, strong correlation there as well. I think that it's, also interesting to note that, for instance, the death rate per million is very much correlated to the number of tests. Now that strength is not to the same degree, which shows that there's other factors involved there as well. Getting at those factors is what a randomized sampling would allow us to do. Well, let me just take for a moment and go back and see how looking at maybe some visual data can also help us to deal with, get a more a real objective view of things rather than the sort of the fear-based news articles that come out. And certainly, this is something that we definitely know about the pandemic, is that it's very connected in with fear. And every time, a new article or whatever goes out that scares a bunch of people, it does what? It gets a ton of hits, and it drives the earning of whoever the media source is. So let's look at a couple of cases. One thing that I've been hearing most lately, and this I'm publishing is July 4th, 2020. Happy July 4th to everyone. I want to say also I'm from Canada, and so just 4 days ago we also celebrated Canada Day, so happy Canada Day as well. What I want to show you here is looking at Arizona. I want to look at Arizona and Florida. These are two states that have come under fire and that have been kind of in the media. Oh, you're not doing the social distancing and all that. I'm not going to make any statements about that because I don't really have any data on that part. What I do have data on is really what I've been illustrating for you, and I want to show you something that is important to understand. It's good to know this for students and any of us, to be able to read the difference between a linear graph and a logarithmic graph and what it really tells us about what is happening. Well, first of all, this is a curve that, is kind of a curve that we would expect to see with total cases. Now, the issues that we often hear is, oh, well, you're not flattening. Okay. What's important to note here is that what we need to look at is the rate of increase. So The logarithmic scale, I want to give you sort of an example to help you. The logarithmic scale is kind of like COVID-19's gas pedal. It tells us the rate of these different things. So the total cases, the logarithmic scale gives us a rate of increase. So what does this tell us? When COVID got started out, it wasn't increasing. And then it hit something, what? Right in the middle of March, and it just started climbing, climbing, climbing. And then it continued climbing all the way through May. The rate of increase of cases has been largely, what? Static. The rate of increase has been largely static. We notice right here, you could say that there was a degree of flattening and then a slight increase. The increases that we're talking about are not congruent with the great dangers and especially what I find the sort of moralizing is that oh, you're a bad state and you're a bad governor, all this kind of things. Certainly, we'll be finding out just more of that as we go along. But the last one I really want to show you is here. Now, if you look at the linear scale, everyone looking at this graph, that's pretty scary, right? That means that our deaths, this is cumulative. All of this is cumulative here, right? So, saying that we have, more deaths, we have more total deaths. The question that we want to ask is, are we flattening? And the way to understand that is looking at the logarithmic scale. Logarithmic scale is, again, this is COVID-19's death accelerator. It is. And what are we learning about that? What we have here is a curve that is moving toward flat rate. That rate of increase is definitely been getting smaller. No, it is not flat yet. We can look at a few examples of that. Let me finish with Arizona, for instance, and now go over to Florida, and you can see some similar aspects. Again, what's alarming is when people are shown this graph, which is to say, wow, we're getting a lot more cases, and this curve is rising. And I think you can make that case right here. But to look at it in a better way, let's look at the logarithmic scale. And this one, yes, you can make the case that Florida, probably of any other of the states right now, is not flattening as much on cases. We see a lot of increase. Certainly, you can easily point to Florida being what it is, and in that way, you might be able to make some statements about the degree of activity. But let's go over here again to this. Now, if you look at deaths linearly, wow, look at Florida's. Florida's deaths has actually been climbed, relatively steady. And let's be clear, deaths are really, I think, the more important measure. You're going to measure, every case of the flu that I get and make, no, I'm not saying that COVID is not more serious than the flu or something. What I'm trying to do is show that numbers we've never had numbers thrown at us like this before. And that's one of the dangers of all this, is having numbers thrown at us without someone giving us a context to which to see them through, is where things get a little bit dangerous. So let me take you back then, just to give a little bit of comparison. We can go back to the USA, for instance, and just look overall at what we notice. And we can see certainly here that cases been going up fairly steadily, but then maybe a slight acceleration. And again, we look at this through logarithmic form. What is something that we noted? I think this is something that I think can be very helpful to understand. So all along the way, in this period, there's been varying degrees of social distancing going on. And as we got into June, what we noticed is that things seem to level off quite a bit. So here we have, right here, let's go up to where we reached the 2 million mark here. On June 7th, we reached that 2 million cases mark. And now, in July 3rd, we're 2.9 million cases. So not the increase, this rapid increase that happened here in the spring. And let's go back and look at deaths. Now we look at deaths here. The death rate, even in the linear scale, even linearly, shows this great deal of decline. Now, this, I think, is probably one of the most important things to see for our old country, and is this. Look at this. This is really a death rate. If we look at this current trend, and this trend over our whole country is unlikely to change. Now, will it change regionally in different places? For sure. But this is unlikely to change unless, what? Some other kind of virus is introduced that's different. So are we as a US, have we begun to flatten our death rate? Quite a bit. Is it like totally like, going all the way down? Not quite yet. So I hope I've given you a few things to look at in terms of understanding some of what's really happening with COVID-19. I think what I want to leave you with is what's probably really critical about that is that when you compare these countries in the Northeast and you try to compare them with other places of, and try to make some kind of claims about success of social distancing, that is really near impossible to do unless it's done where you can control all of these other variables that are also involved. And I've mentioned a few of them. I'll kind of wrap them in closing to wrap them up. We know that COVID thrives in in cool, wet, and cloudy weather. So that right there is a factor. And we also know that population density has a huge impact on these other factors. The degree of movement and activity is pretty important. One really brilliant person went and did cell phone movement, like tracking cell phones as a way, kind of correlating between new cases. Very good measure, of course, on that. Again, I'm going to make the case here that, yes, mass social distancing, I'll continue to do that. But I share all this mainly because I just want to reassure people that the death rate that's reported is actually way higher than the actual. When you look at any one of these particular rates, what happens is as soon as you take into account all the symptomatic, the asymptomatic cases. So, for instance, let's say that we were to go to California, for instance, and we say that we have this many total cases, 250,000. There are 4 million people in our state. How likely is it that those are the only infections that we know of? Extremely unlikely. And most epidemiologists would agree that that number must be multiplied by 10. So what happens when you do that? What happens when you times the real cases by 10? This is what happens right here. 0.25% death rate. Now, if you look at the numbers, you'll see that the death rate from general respiratory viruses is probably a little bit lower than this, in the 0.1 range. Now, I'm not saying that COVID is not serious. The way in which COVID is serious is the way in which it goes undetected, and the way in which it's very contagious. Is it sad that people are dying? Of course it's very sad. I just want to be clear that when we use real data, we can make real conclusions. So I hope this has been helpful to my students and anyone else who's checking this out. Hope you have a good day.